My name is Mark Goodluck from Ewosa Anglican Grammar School, chemistry teacher. Today we'll be looking at the topic stoichiometry. First of all, what is stoichiometry? Stoichiometry is the quantitative relationship between reactants and products in a chemical reaction. Basically, there are three types of reactions. Three types of conversions in stoichiometry. The first one is the mole-to-mole conversion. The mole-to-mole conversion, that is conversion of a substance A, the mole of a substance A to the mole of a substance B. Secondly, we have the mass in gram of a substance A converted to the mass in gram of a substance B. And third, we have the conversion of the mole of a substance A to the mass of a substance B, or you see the mole of a substance B converted to the mass in gram of substance A. So these are the three major conversions in stoichiometry which we are going to be looking at today. The first conversion, to achieve this first conversion, what you do for the first conversion is we use the mole ratio of substance A multiplied by the mole ratio of what is given in the equation. We use this simple formula 1 over what we have, and this will give you the conversion of the mole of a substance B. So let's look at a simple reaction between hydrogen gas and oxygen gas to produce water. Hydrogen gas reacting with oxygen gas to form water. Now in this reaction, whenever you're given a reaction, first of all you balance it. This reaction is not balanced. To balance this reaction, you have to put a 2 here and a 2 here. And this is 1. And now this equation is balanced. Once your equation is balanced, the coefficients, these are the coefficients 2, 1, and 2. The coefficients act as the mole ratio, and that is what we are going to be working with throughout the calculations. So the mole ratio here is 2:1:2. So these are the mole ratio of this chemical reaction. And now we look at the equation here. Hydrogen gas reacts with oxygen gas to form water. This is the expression. Once hydrogen gas reacts with oxygen gas to form water, that is 2 molecules of hydrogen gas reacting with 2 molecules of oxygen gas to form 2 molecules of water. Now from question A, how many moles of oxygen gas are needed to react with 4 moles of hydrogen? And now we see here, we are dealing with the mole-to-mole conversion. So dealing with the mole-to-mole conversion, we are going to be using this first conversion here, which is conversion of the mole of a substance A to the mole of a substance B, and applying this simple formula I just dropped here. Now, the mole of a substance, mole A, is for oxygen gas, while for mole B is for oxygen gas, which is what we are looking for, while mole A is what we are given in the equation, which is 4 moles of hydrogen gas. And now using this formula we have here, mole A is what we are given in the equation, so we can say this is what is given. multiplied by the mole ratio of what we have over what we want over what we have. So from here, mole A is what is given, which is 4 moles that was given in the equation, which is what we can see. So we say 4 moles hydrogen gas reacting with the mole ratio. What we want is the oxygen gas, the mole of oxygen gas, which is stated in the equation, how many moles of oxygen gas. So that is what we want. It's always at the numerator, and what we have is always at the denominator. So what we want here is oxygen gas. And the mole ratio from this mole ratio we have here, the mole ratio of oxygen here is 1. So we say 1 mole oxygen gas over what we have. We already have what? Hydrogen gas. Since we are working with hydrogen gas, we use the mole ratio of hydrogen gas, which is 2. 2 moles hydrogen gas. Now the conversion will give us the essence of using this 1 over half, so that the units mole of hydrogen gas can cancel this mole of hydrogen gas, and we'll be left with this unit mole, which is for the what? Conversion of B. So we are converting mole of A to mole of B. So this 2 times 1, we will be having 2 moles oxygen gas. That is to say, 2 moles of oxygen gas will react with 4 moles of hydrogen gas to produce water. So this is for the first one, A. And now moving to B, it says how many moles of hydrogen gas are needed to produce 2.4 moles of water. So here we are also dealing with the mole to mole conversion, but the difference here is that this is hydrogen gas, this is the reactant, and this is the product. The difference for this one is this is a reactant, this is also the reactant. And we worked with the mole ratio of this reactant to the mole ratio of this reactant, which is 1 and 2. So for the next one, we are working with the mole ratio of this reactant, hydrogen gas, and the product, which is water, using the same formula. So for B, the mole, we are converting the mole of substance A to the mole of substance B. For A here, A is what is given, as I said earlier. What is given in the equation here is 2.4 moles. 2.4 moles H2O. So we multiply it with 1 over half. What we are looking for is hydrogen gas. So that's what we want. So we are using the mole ratio of hydrogen gas to the mole ratio of water. So the mole ratio of hydrogen gas here is 2. So we are using 2 moles of hydrogen gas over what we have. So what we have is water. So we are using the mole ratio of water here is 2. So we say 2 moles of water. So moles of water can cancel this mole of water. So we'll be having the mole of hydrogen gas. So if you do this division, we'll be having 1.2 times 2, which is still 2.4 moles of hydrogen gas. So 2.4 moles of hydrogen gas is what is needed to produce 2.4 moles of water. So now moving over to the next one, which is C. How many grams of water is produced if you react 10 grams of oxygen? Now in this reaction, we are converting grams to grams. It's a different approach concerning this first and the second question we just solved. We use a different approach. And solving this first and second one, we use only this first one, the mole to mole conversion. But for the question C, we are using the mass to mass conversion, which we are going to look at now. So for the next one, to mass to mass conversion. The mass to mass conversion can be in a chain format, or we can apply. We are going to be using two different methods here. The first method, either you use the chain method or you use the separation method. What I mean by the separation method is, at first you have to convert the mass in gram of the substance A to the mole of substance A. Using this one, for the next step, you convert the mole of a substance A to the mole of a substance B. And lastly, you convert this mole of substance B to the mass in grams of substance B. So this can also be the separation method, whereby you solve this one first, then you use the answer, which is the mole of A, to solve for the mole of B. Then lastly, you use the mole of B, the answer you got here, to solve for the mass of B. So now, using the first expression here, converting the mass of A to the mole of A. We were given the mass here, the mass of oxygen, which is 10 grams. So using 10 grams of mass of oxygen, this is what is given, then this is what we have. Or that's what we want. So you say the mass of A to the mole of A. So now the mass there is 10 grams. 10 grams of oxygen multiplied using the mole ratio. Remember, our mole ratio is 2:1:2. And this is for hydrogen gas, this is for oxygen, and this is for water. So the mole ratio there is 2:1:2. Since we are dealing with mass of A to mole of A, we are only going to be working with the mole ratios of A. And what is A here? A is your oxygen gas. So A is your oxygen gas. Now we have 10 grams of oxygen gas multiplied by the mole ratio of oxygen gas there. Oxygen gas, the mole ratio of oxygen gas is 1 mole of oxygen gas over, we are going to be using the mass. Now we are using the molecular mass of oxygen gas, which can be gotten from our periodic table. We know that oxygen has an atomic mass of 16, but here we'll be looking for the molecular mass because oxygen exists in a diatomic molecule here, a diatomic state. So using O2, we say 16 times 2, or we say 16 plus 16, which will give us 32 grams. So the mole ratio here is 1 mole of oxygen gas over 32 grams of oxygen gas. Since we are converting the mass of A to the mole of A, this is the expression we use. The mole ratio from the reaction over the molecular mass of that element. So doing this, we have here this gram and oxygen gas. We cancel this gram of oxygen gas. Remember, when your units does not cancel out, it means you are not in the right track. But arranging it in this format, you must make sure each unit cancels out. Once your units are able to cancel out, to give you the required unit of your answer, you know that you are in the right track. So this will be 10 times 1 over 10 times 1 over 32. That would be 0 points. Okay, so this will be 0.312 moles of oxygen gas. So here we have converted the mass of oxygen to the mole of oxygen, which is the first step. So we have gotten this first step, the mass of oxygen to the mole of oxygen. Secondly, you use your mole of oxygen, convert from this mole of oxygen to the mole of what is required, the mole of B. And what is B now? We are dealing with oxygen and water. So the mole of B represents the mole of H2O, which is the mole of water. So here we have, second step, the mole of A converted to the mole of B. So what is the mole of A now? The mole of A is 0.312 mole of oxygen. Mole of oxygen multiplied. Remember, converting mole to mole, according to what we did in the first step, in the first equation, converting mole to mole, we use the mole ratio of what we want over what we have. So mole to mole times the mole ratio of what we want what? Water. And from here we have 2 moles, the mole ratio of water there is 2. So we have 2 mole H2O over what we have. Already we have what? 4. So yeah, the mole ratio of what we want over what we have. What we want from the equation is what? 10 is H2O, which is water, over what we have. What we have is 1 mole. 1 mole of oxygen. So now, the mole of oxygen, cancel this mole of oxygen. So here we are having 2 times this, 0.624 mole H2O. So this is our second step. We have converted the mole of A now to the mole of B. And lastly, we convert this mole of B to the mass of B. Lastly, we convert our mass, we convert our mole of B, the mole of B to the mass, in gram of B. So the same process we applied in this first step here is the same process we're also going to apply in this last step, but vice versa. Now the mole of B here is our mole of water, which is 0.624 moles. 0.624 moles H2O multiplied by, from this first step, I said what we have here, we give what? Mole of oxygen to the molar mass of what? Of oxygen. So same thing here, we are dealing with. Now, this, like I said, is vice versa. Here we have mole. We are starting with mole. So instead of saying 1 mole of H2O over the molar mass of H2O, this expression will be wrong because this unit, gram of H2O, cannot cancel the mole of H2O. So it is the reverse. So what we'll be working with is the mass, molar mass of the compound H2O, which is what? Hydrogen, the atomic mass of hydrogen is 1 times 2 plus 16. So this will give us what? 18 grams. So the molecular mass of this compound is 18 grams, which is what we are going to be working with. 18 grams H2O over the, what is our unit? This is 0. We are not using 2 mole, we are not using this mole ratio of 2 here. Instead, we are using 1 mole H2O. And why are we using 1 mole of H2O? Because the unit for relative atomic mass is, relative molecular mass is 18 grams per mole. So our unit we are working with is gram per mole. Gram per mole, which is what? Gram per mole. That is why we are not using this mole ratio here of 2. We are using the mole ratio here from this unit. So this is 18 grams H2O over 1 mole H2O. The mole of H2O, we cancel the mole of H2O, we'll be left with gram, which is from mole to gram. So 18 times this, we are having 10.8 grams of H2O. So finally, this is our answer. Converting from mass of A, the mass in gram of A, to the mass in gram of B. And the mass in gram of A is 10 gram. So 10 gram of oxygen gas will yield 10.8 gram of water. So that is that. So for today, I'll be leaving you with these assignments. Following the same process, it will be easier for you to solve. I want you to remember something. Now, we did not talk about the last conversion. This is number 2. Number 3 conversion is the mole of substance A to the mass in gram of substance B. Or we say the mass of substance A or B to the mole of the substance A. Now, this third expression can be found here, where we are converting mass to mole. This is mole to mass, mass to mole. So this number 3 conversion can also be found here. There are some cases where you need only this conversion, so you need to apply either only this step or only this step. This third one. Thank you. So this is the assignment I'll be leaving you with. Sulfur dioxide reacting with oxygen gas to form sulfur trioxide. Like I said, the first problem to stoichiometry, the first solution, what you do, you write down your equation, you get your formula for sulfur dioxide, react it with oxygen gas, then you form a product. That's the first step you take. The second step you take, you balance your chemical reaction. After balancing your chemical reaction, you look at your equation, look at what you're asked to convert. This is moles to mole. So you know which formula to use. And you use the first method of conversion, which is mole to mole, using your mole ratio of what over half. Secondly, how many moles of oxygen gas will react completely with 4.7 moles of sulfur dioxide. So also, this requires what? Mole to mole conversion. Thank you.